All right, good afternoon, everyone. Hello, and welcome to our webinar, The ABCs of PLCs. I'm John Ricco, APA Executive Director. Thank you for attending today, and thank you to our presenters for taking the time to participate. We're going to jump right into this session. So those of you who are logged in via YouTube, you can submit your questions through the YouTube chat feature. And those of you, if you're not logged into a YouTube account, throughout the webinar, there will be a pop-up that shows intermittently letting you know where you can send questions via email. So please feel free to submit them that way. We have two presenters today. We've got Jamie Farney and Joe Diedrich. Jamie is with the Portland Cement Association, where he promotes the use of cement-based materials for various applications by focusing on sustainability, resilience, energy efficiency, durability, and other key benefits. He participated in the development of the PCA's roadmap to carbon neutrality and the campaign to raise awareness of portland-limestone cements for improved sustainability and concrete construction. He holds a BS degree in civil engineering from the Illinois Institute of Technology. Joe is the manager of technical services for Federal White Cement. He's been in that role for over 5 years, and prior to that, he was technical service manager for a large gray Portland cement company for 28 years. He's a member of several organizations, including ACI and ASTM. He's been an active member of the PCA Limestone Task Group since its inception in the early 2000s. So welcome to both of you, Jamie and Joe. And I will go ahead and turn it over to you, Jamie. Hold on just a second, Jamie. You're having trouble unmuting you.
Okay, I've got it unmuted. I'm sorry about that. So I wanted to thank you for the nice introduction. I said, I'll just leave my camera on here to start so you know there's a real person behind this. It is live. We appreciate being able to share this message about PLC with you. It is a really exciting time. So again, I'm going to turn off my camera here and then we'll get started. So about 2 years ago already, we kicked off right at the beginning of the pandemic, a Shaped by Concrete campaign. So we represent cement manufacturers at PCA. We represent the majority of the production in the United States. And we wanted to tell the message about concrete and about cement, how important these are to our world. Modern society really has been built using cement and concrete. We literally are the foundation of our society. We have a great industry, we provide good jobs, and we help to create a resilient nation. You know, we are responsible for housing people and for manufacturing sites and for dams and roads and other kinds of infrastructure, things that we rely on to move ourselves around, to move goods around. So we just wanted to remind people how important our products are. And as part of that, then we said, you know, everybody's focused on carbon right now and changing climates. So we developed a roadmap to carbon neutrality. We just celebrated a 1-year anniversary of that. And in it, we acknowledge that as a manufacturer of a manufacturing industry, we do have a carbon footprint. We are responsible for, as you see at the bottom on the right there, about 1.25% of the CO2 in the United States, according to the EPA. So it is a footprint, but it is actually lower than quite a bit of other industries. And so we just said, you know, how are we going to position ourselves that we can keep making this really critical material for society and yet do better at what we do. So our members got together. We worked on this roadmap to carbon neutrality. Many industries are doing this. 2050 is kind of a common target date for everybody. And we looked at CO2. We looked at it in terms of sustainability. Again, we have a resilient product. We are the foundation of really everything that is built. So we know there's increasing interest in reducing our environmental impact of all building materials. You know, designers are paying more attention to it. Government and regulators, even the public is saying, you know, what kind of world am I leaving for my kids or my grandkids? So again, concrete's really essential. We need to move people around. We need to move goods. We need to have protection on our waterfronts. So what can we do within that context of providing this really valuable material to address climate issues? We know blended cements are one way that we can help make concrete more sustainable. So in this roadmap, We looked at clinker, cement, concrete, construction, and carbonation. We looked at the things that are really critical in terms of that whole manufacturing process, and we called it the 5 Cs. And we said, every one of them kind of has an area where we might be able to pull carbon out. So we broke it up and we were very methodical about looking at everything. And I want to focus on just a couple of them. And optimizing cement was something that our manufacturers identified as a real key area where we can have a significant impact. So clinker is what we manufacture from these materials that we mine out of the ground, and then we grind that up into the powder that is Portland cement. So what is the appropriate clinker to cement ratio? How much clinker do we really need for cement to be able to do its job? So we're looking at modified formulations. And one of those we're focusing on quite heavily today is making sure that people understand and at least allow as an alternative Portland limestone cements or PLCs. That's a big focus. It's just building awareness, educating people about its performance and its benefits. We know that there's other cements that will come online over the next really 3 decades, things that we maybe don't even know right now. And we're also looking at, well, how do we move those materials around? In manufacturing and in transportation, there's opportunities to have fewer emissions. So a big part of it is the focus on cement. But again, as part of this 5 Cs value chain that we speak about, we also recognize we can optimize concrete. Concrete producers have a role. We don't build with cement, we build with concrete. So what can those people in that part of the industry do? They can optimize mix designs, improve mix designs. We can increase our use of SCMs, supplementary cementitious materials like slag and fly ash and silica fume and other additives. These are often byproducts of another industry. Sometimes they end up in landfills or as waste, but we know they can be beneficially reused in concrete. And in the US, at least, they aren't always given the same environmental footprint that other materials are, so they can help bring down the carbon footprint of concrete. We can reduce the energy consumption in our concrete plants and the way that we deliver those materials. There's, again, opportunities to pull carbon out. And we, again, recognize we probably don't even know all the things that are going to come online in the next 30 years. We just know that people will improve processes. People will come up with better, more innovative ideas. We know that right now, though, PLC is one option to lower the carbon content of our binder. And it is, again, acknowledging the CO2 footprint of construction. We're aware of it. Is it a problem or is it an opportunity? Because when you have a lot of carbon, you maybe have the most knowledge on how to deal with that. PLC is a proven technology. You heard in the introduction, Joe has been part of the task group and the different subcommittees and committees at PCA that have been working on bringing PLC into the standards appropriately. So we know that PLC can help make concrete and masonry products more sustainable. This may appear to be happening very quickly, but the work behind it and the research goes back decades. So what is PLC? What is Portland limestone cement? We like to say it is a greener cement option. It is a blended cement, and it has additional limestone content in that cement. And then that overall cement is optimized for performance. So right now, at least, it is the easiest way to reduce the carbon footprint of products that are cement-based by up to 10% over the more traditional Portland cement mixtures that you probably are familiar working with. You can use it in anything, in any kind of infrastructure application, roads and pavements and buildings and bridges. You can use it in also, it's available throughout the country, throughout the US and Canada. So if we want to understand a little bit more about what it is and how it behaves, we can look at just that sort of 4th step in cement manufacturing. After we mine materials out of the ground, we grind them up, we blend them to get the right chemical formulation, and then we send them through this kiln or long rotating oven. This is kind of the 4th step, is Now we're going to blend the clinker with other materials when we grind them. So we do that with Portland cement already. And where you'll see the difference is we have a little bit of limestone in Portland cement, up to 5%. Where the PLC is just slightly different formulation is that we can go from 5% up to 15% of ground limestone. So that's one key difference right here, is the proportion of the materials. The other key difference is that we get a longer grinding time. Again, we're going to be making a very fine powder out of this. So we speak about the fineness of Blaine, of Portland cement as a Blaine number typically. And with a Portland cement versus a Portland limestone cement, we're going to be increasing that Blaine by about 100 meters squared per kilogram. So it is a measure of the surface area to the mass of material. Most Portland cements are going to be in the upper 300 to low 400, maybe mid 400 range. So the Portland limestone cements are going to be in the mid 400 to upper 400, over 500 maybe range of fineness. So that's one of the ways that we are modifying the cement itself after we add in a little bit more limestone, but we also do some other optimization that includes balancing the chemistry. So we do things a little bit differently at sort of almost the end stage of manufacturing of these cements to make sure that they're going to perform very similarly to that type 1 or 1-2 Portland cement that is the most common material used for concrete right now. So limestone, you can't think of it as sort of a dilution or just this thing that we throw in, without thinking about it. There's really benefits of using limestone in cement. As I said, the Portland cement standard allows for up to 5% limestone. So if these are the clinker particles that we're grinding up, we can add a little bit of limestone in. This is just an idealized sort of cement graphic here. We actually add some other materials in as part of the cement formulation too. But if we look at just whatever else is in there versus limestone, 5% limestone, we always have to stay below that limit to be able to meet the standard. So we never quite reach 5%. Similarly with Portland limestone cement, these are the other materials, and the limestone is that 15% portion up to always below it. But why is this working for us? How can we get the same performance if we're adding in more limestone? There's 3 key reasons why. One is particle packing. That's idealized here in this figure at the left. These larger red particles would be cement particles. And because limestone is just a little softer than clinker, when we grind them together, the fines typically really are produced more from the limestone portion. So these smaller particles are filling in between cement particles, which are themselves pretty fine already, right? But we're filling in between them. So we get this particle packing going on. That means we have a tighter matrix. Everything fits together just a little bit better. We've got an improved particle size distribution. So we don't have one size of everything. We've got this nice blend from the larger down to the very small particles, submicron kind of particles. So that's one aspect that really plays into strength gain because we have such a tight, dense matrix. We can get improved strengths because of that. The particles are actually touching contact, particle to particle contact. That's one reason. We also have, as a result of that, lower permeability generally in Portland limestone mixes. So most durability issues are something trying to work its way into that concrete matrix. So it's water and aggressive ions that are carried in with the water. So if we've got a tighter matrix, we can often see improved durability. So that's the first thing that limestone is doing. Another thing is we have this nucleation effect. So if these sort of orangey or darker yellow particles are cement particles, and then the lighter yellow is a limestone particle, you can see, the idea of them being smaller. Well, when we mix cement and water together, the cement starts chemically combining with, reacting with water. It's hydration. And it's not really dissolving, but that cement particle, as it combines, it starts creating this cement gel. That's what knits concrete together. That's what gains strength. That's how it gains strength. So this smaller limestone particle it provides another location for that gel to start growing. It's like a little anchor that we can start growing gel around it. So it surfaces for precipitation, for this cement gel to grow and strengthen that matrix and develop strength. The other third part of why limestone is really just such a good thing to add to Portland cement is that we get a little bit of reactivity when we grind our limestone so fine like this is. So you might have some small chemical reactions, just a minor contribution, but remember there are charges on these particles. So we do see a slight improvement in the chemical reactivity of Portland limestone when we grind it so finely. So again, Joe has been involved in this activity as a cement manufacturer for decades. We have done a lot of standards work. I said it may feel like this material is all of a sudden kind of appearing out of nowhere. Where's Portland limestone cement coming from? You know, I hear a lot about that now. Well, really, we've been working in the standards to make sure that all the technical information was in place to be able to use this to introduce it. So we've got that C150 Portland cement standard that's been around, you know, for a very long time. It allows up to 5% limestone for almost 20 years here in the US now. Type 1 or a type 1-2 is going to be the most common. So what we're talking about is a material that can perform a lot like that, but it comes under a different standard, the C595 blended cement standard also from ASTM. It shows you that 5 to 15% limestone limit. So that's spelled out in the standard. Any material that we're manufacturing that's called a PLC or a type 1L has to have in between that range of limestone. We can also have another, we have some other cements in that standard. They're pozzolan and slag materials. So pozzolans are like fly ashes and there's natural pozzolans too. Fly ash comes from the power industry. When we burn coal, we catch what goes up the smokestack, and it actually is a really good addition to cement and concrete. So we have these type 1P and 1S materials, but we also can have a third or a fourth actually cement, a type 1T, and it allows for the addition of limestone and or pozzolan and or slag. So we have to have clinker in there. The 1T means it has 3 components. So the 2 other components are something that isn't clinker. It can be a combination of pozzolan, slag, limestone. It can be 2 of pozzolans and slags with a limestone. So we are just introducing the idea that type 1L is the most common PLC or Portland limestone cement that you will see on the market right now. But many of our members may be investigating these type 1T cements also going forward, where they have something in addition to clinker and limestone in them. You can specify a PLC as a 1T. So that's probably coming in the future because we're still trying to reduce the footprint. We also have this third standard for Portland cement type materials, hydraulic cement. And this is a C1157. This is already a 30-year-old standard. It's not produced by all members. It really kind of depends on what materials they have available in their market and if that manufacturer sees a benefit in it. But it kind of allows them to innovate a little bit more in their cement manufacturing. They aren't tied to the same requirements as a C150, like in terms of ingredients would require them to do, but it still has to demonstrate performance. So it's actually called the performance standard. This also can contain limestone in varying amounts. They have other designations. So if you see a type GU, a general use cement designation, or an HE, high early, or an MS or HS, a moderate or high sulfate material, resistant material, then you'll understand it's just another way to specify a cement, and it actually has requirements for performance it has to meet, but it'll also behave like a Portland cement or like a PLC. As those are the cement standards that are then recognized by the concrete material standards, like C90 for load-bearing concrete masonry units, or C94 for ready-mix concrete, or C476 for grout for masonry. All of those standards recognize any of those 3 cement standards, and they say, hey, we can use all of these materials more or less equally, and we can still use our supplementary cementing materials, or SCMs, along with them. So I've kind of touched on the idea that these are not new materials. They've been around for a while. There's actually a really long track record for limestone containing cements. Within the US, we have a little bit less familiarity with them until really a decade ago, but there's a very good history of performance, and we're even talking at above that 15% limestone content that we limit it to by our standards in the US right now. Europe has had these kind of materials since the late 1960s. So we're talking about, 50 years ago, more than 50 years ago. Canada has been using them since the late 2000s. So they were just a little bit ahead of us in terms of accepting or adopting these kind of materials. But our standards, as I mentioned, have been in place since 2012. And then there were a few manufacturers who already saw the benefits of this kind of movement back in the early 2000s. So under that C1157 standard, that performance cement, they had to demonstrate that it actually achieved strength, and it set final set and initial set the same kind of way that we expect the Portland cement to behave. They already started manufacturing these cements under this other standard. Again, it wasn't widely embraced, but they were out there. We have already then more than 15 years of experience with these kind of cements in the US. What we also know is that our market share for blended cements will grow. We've seen this in other countries as people get familiar using them. And then just a few years ago, we were tracking under 2 million metric tons of Portland blended cements. We're already seeing over 4 million metric tons last year, and we've seen a dramatic increase this year. So let's shift to mixed designs with PLC, about the proportioning, batching, and mixing aspects of these materials. Remember, cement manufacturers optimize PLC. They're doing it so that we can replace ordinary Portland cement at a 1-to-1 ratio. They want to make this a drop-in technology, if you will, that I take out one material, I allow for another material, I use them the same way. It's not a heavy lift, it's not a heavy burden for users. We don't want to upset sort of the business as usual practice. We're just having another option for material that people can choose to specify. As I mentioned under the standard slide, you can still use the same dosages of fly ash or other pozzolans, of slag cement, of silica fume with a PLC. They work really well together. But I will say, anytime you change a material, and you probably have experience with this if you're a producer, it's a good idea to understand how that material will affect your fresh and hardened concrete properties. What are the effects on that? So things like air content and slump, bleeding potential. Remember, these are very finely ground cements now. The bleeding is probably going to be impacted somewhat because you have a lot more fines that hold things together, hold the water in that mix better. We have to check the setting time, both initial and final. We got to look at compressive strength. I did this for a cast stone group not too long ago. In that particular part of the industry, they're very concerned about absorption and freeze-thaw mass loss and shrinkage. So their standard requires either having limits on these or sometimes at least reporting how those things are affected. And what we hear from many parts of the industry, remember this information that you're seeing today is largely focused at ready mix. But what we're hearing is that some producers report that they really don't make any adjustment once they do that 1-to-1 swap. Others are saying, I may have to bump up my admixture dosage or bump it down. I'm seeing just a little bit of difference in what I get out of my concrete mixes. So I know how to control with admixture technology. So if we look at then the typical effects on the fresh and hardened concrete properties when we put PLC in instead of Portland cement, we look at the fresh properties like workability, bleeding, setting time, heat of hydration. If you're doing very massive things, that can be a consideration. We look at the hardened properties like compressive strength and our scaling or freeze-thaw resistance and our sulfate resistance. So in every case, we can see maybe a slight increase or a slight decrease, but not a big impact on any of these. And the reason, again, is we're talking about very similar cement chemistry. These cements set and harden the same way that a Portland cement does. They are largely Portland cement based. That little bit of extra fine stone of limestone, and because it's a finer ground cement overall, it may have some slight impacts. Maybe it's going to decrease your bleeding, your overall bleeding. It may delay it, it may decrease it, because again, the mix is very tightly bound with that particle packing going on. The water can't work its way to the surface. You might see a little decrease as your materials get finer, but at the 15% limit that we're talking about, the setting time, that slight decrease that you might see, either initial or final, it's really manageable. And if it is somehow a concern, again, you can turn to tweaking your admixtures a little bit. Compressive strength, both the early and long-term strengths can increase. And it goes back to that slide about the particle packing, the nucleation, the slight reactivity when we grind limestone so finely. So strength is actually something that's pretty well figured out. The durability aspects, like scaling, freeze-thaw resistance, I think for a lot of the products that APA producers would be concerned with aren't necessarily going to see de-icer application. So I'm going to have a slide on the freeze-thaw resistance. So that's cold temperatures, but in the absence of de-icing chemicals. And then sulfate resistance can be an issue in certain parts of the country with, high sulfate soils or industrial processes that have a lot of sulfates in them. But the message for all of those durability issues is that whatever you're doing for your ordinary Portland cement mixes, whether it's a proper air void system through admixtures or good curing or turning to higher strength or using an SCM as part of your mix, whatever you do for your ordinary Portland cement mixes, you do the same thing. You take the same approach with the PLC, and then you test and you confirm, is it a good performance? So I just talked about sulfate resistance a little bit. You may have, depending on your cement supplier, an option to specify a special type of cement. For instance, for sulfate resistance, we can append an MS or an HS designation to our type 1L. So where we have a type 1, we just put in a type 1L. If we have a moderate sulfate resistance type 2 material that we typically use, talk to your cement supplier. They may supply a type 1L MS. This material would be tested to demonstrate that it can resist sulfate expansion under exposure to sulfates, and it has to be tested in order to receive this MS designation. Similarly, if you use a type 5, you might have a high sulfate resistant type 1L available to you. In August of last year, the standard, the C595 standard, was changed to allow producers to produce a type 1L HE or high early strength material. And this is comparable to type 3 high early strength Portland cement. So the idea is always talk to your supplier. If you have an option to specify a special property that you require for your particular products, you may be able to get it from your supplier. If you can't, if those special characteristics are not manufactured by that supplier that you use and another one isn't available, you can use admixtures to achieve those kinds of performances as needed. So let's talk about, again, this is designed to be drop-in ready. This is a technology, a one-to-one replacement, swap it out, you're good to go. You have the same operations for placing, for finishing, for curing. Now with curing, I will mention, as you see that fineness increase, because these are finely ground cements, you might see a little bit less bleed water. Maybe you can get on your slab sooner. You might see a little bit of a reduction in setting times. You might, because again, that strength is kicking off pretty quick. You might see a little higher water demand. This is pointing back to that importance of knowing your materials and your mix designs and testing, understanding them. The message here, though, is it's virtually the same handling and performance as ordinary Portland cement concrete. It's designed to be that way. You have the technology that you use with OPC mixes. You can turn to that same kind of approach for a PLC mix. And that picture I'm showing at the right is a zero slump barrier wall made with PLC. It's up in Canada. It's been performing really well. So again, we can take these from normal workability kind of mixes down to the very low workability mixes and stiff and extruded, and they can still perform well. We can talk about the performance of PLC concrete, those hardened properties. This figure at the right is a very important figure. It has pairs of graphs that look at, in the yellow or tan mixtures, bars, these versus the green ones are for 0, 25, 40%, and 50% SCM replacement levels. So these have no SCMs at the left. These have only 50% PLC or Portland cement with a 50% SCM blend in them. And we look at the strength from 3 to 7 to 28, 35, all the way out to, we even take a core at a year. And you can see within each set of graphs that the green or yellow, tan, they are almost identical overlays for each other. So this is telling us we get the same ultimate strength with a PLC mix. We also get the same strength development with a PLC mix. So we figured out compressive strength. You can do it with or without supplementary cementing materials. If you need those for either a durability aspect or to bring down your carbon footprint because you have fly ash or slag cement that doesn't have the same CO2 footprint as cement, they work well together. That's the bottom line message there. Now, I focused on shrinkage and durability. I want to talk about those a little, especially the freeze-thaw resistance aspect of PLC mixes. But for shrinkage in particular, I think, precast, you make your materials and then you send them out to the job to be erected on site. So we've got a comparison of our total shrinkage of, in the red, a 0% limestone to a 5% in blue and a 10% limestone in black. And this is showing the average strain, right? So the larger the strain, the greater the shrinkage. So you can see out to this 3 months here that the red or the 0% limestone, so that'd be more like a Portland cement mix, it actually shrinks a little bit more in this particular set of materials than the 10% limestone mixture. So that's telling us that limestone is just reducing our shrinkage a little bit, which maybe helps with cracking just a little bit. Again, understand your materials, study your materials, work with them, know them, but limestone added to cement should not be affecting shrinkage in a bad way. That's the message there. I said I'm not really covering freeze-thaw. I can point you towards some information if you want to follow up on freeze-thaw, de-icer scaling resistance, but I am talking about freeze-thaw, where we've got in this set of materials, we've got the blue bars are Portland cement, the yellow are a 12% Portland limestone cement mixture. So 12% limestone in the PLC. So this is a durability factor where we expose this sample to freezing and thawing in water or air, and we cycle it. And you want to get 300 cycles usually. We see that even at different water cement ratios, 0.4 and 0.45, with no SCM, you see very good performance. These are durable materials. They can freeze and thaw. They can be exposed to cold weather. They're not falling apart. If we add slag in at 35% or fly ash at 20% to either the Portland cement or the Portland limestone cement mixes, we still get across the board pretty much 100 durability factor. So that message here is these can be freeze-thaw durable materials. You don't have to worry that PLC is somehow going to make you non-durable in a cold climate. It doesn't happen. We've documented all this performance and more where we look at the fresh and hardened properties like workability and bleeding and setting time. We've got a lot of data pointing back, again, decades. We look at the strength and volume stability, so that shrinkage or cracking aspect of Portland cement versus Portland limestone cement. We look at durability issues, transport properties. Again, how do chlorides, how does water work its way into our concrete mixture? So on the cement.org website, we've got a PCA report called serial number 3148. Under our frequently asked questions on cement and concrete, What is Portland limestone cement? You'll see a map of the US and below it, a link to this state-of-the-art report that we have put out. It's 10 years old. We're working on an update. I would caution you, if you do go to read it, that some of the information on sulfate resistance has 10 more years of data behind it now. So we are updating it. The sulfate recommendations in that report are just a little out of date because we know a lot more about them now, and we have a good understanding of sulfate resistance of PLC materials. So that map that you saw, it's really with the DOT, the Departments of Transportation, acceptance of PLC around the country. Many DOTs have studied PLCs because they say, I know there's all this data. I know people have researched it, but I still want to be able to make informed decisions about PLC in my market, with my aggregates, with my mix designs. So I believe what you say, but I still feel more comfortable studying it so I understand how it's going to perform where I am. So Oregon State did this comprehensive PLC research program for Caltrans, the biggest DOT in the country. And what they found was, again, similar set time, similar shrinkage, similar time to corrosion, similar or improved ASR performance and sulfate resistance, even a little better flexural strength when you mixed it with slag. But again, very comparable performance. So Caltrans updated its specs in October of 2021. We talked about how do you get these materials? What's the basics of specifying and ordering them? These are called a type 1L cement. So you revise your specs. You can replace OPC with PLC. It's 1-to-1. If you use 564 pounds of OPC, you could put in, I'll allow for 564 pounds of PLC. You use the same ready mix suppliers, the same delivery and placing equipment. Again, it's designed to be sort of a drop-in material, ready to go. The DOTs have embraced Portland limestone cements. Why is this change happening? Again, we developed this roadmap to talk about where all industries are going to look and think about their carbon. How can they do better? The DOTs have been very focused on, studying these materials for their own mixes. And most of the country is now, there's actually another state, I believe Maine has now accepted this too. But we see that they're really driving it. They are one of the biggest users of cement. So kind of like what they need or what they say, that's what's going to be a trend for the industry. So all you have to do in your specs is allow for a C595 type 1L cement instead of, or as an option to, a C150. I don't think most of you are working with AASHTO, the State Highway Transportation official specs, but we have a harmonized spec for that as well. We've got a great website for you, sort of a resource called greenercement.com. Really easy to remember. It's got calculators in there to help estimate what your CO2 savings is. It talks about the benefits of PLC like we covered today, but in a little more depth. It gives you some very specific specification language. It has case studies in there. It's really designed to educate and build awareness, and be a place for you to go if you have questions. So in that spec language, for instance, on the main page, how do I specify a PLC? If you click on that, you'll pull up a document with language that is really easy to show you. And I'll pull out some sample from the AIA master spec. In it, you'll see you have to kind of go in and check off what materials are allowed. I want a type 1 white cement, or in the 595, I want to see 595 type 1L cement I'm going to allow here. So again, the spec language should be updated. Look at your specs, make sure you allow for this type of material. You don't have to specify it and mandate it, but you should allow for it because it will work. We've got a website that has a map on it too, that greenercement.com. So the producer members of PCA, plants and terminals throughout the country. This is not everybody, it's the PCA members, but these pins mark locations, and they've got contact information so you can help source PLC if in your area you are having trouble finding it. We've got on that website, again, some case studies. I show here a building at Drexel University. They were very committed to sort of green principles. All we have to know about it is it's a 450,000 square foot building to plug it into our quote unquote basic calculator to see that we get 314 metric tons of CO2 savings switching from ordinary Portland cement to Portland limestone cement. And then we can go to the EPA. They've got these equivalency calculators where it's like taking 68 cars and driving them for a year, or driving almost 800,000 miles in a car, or we've got, trees growing seedlings and forests, and how much CO2 is sequestered in a forest or stored in a forest. So we've got these equivalencies that kind of start adding context to the change that we're making and what does that mean. We can demonstrate our CO2 savings on just a volume of concrete. So we can take what our total volume of concrete, maybe that's a day's production or a week's production, and our typical cement factor, and we can come up with our savings for that. So we can demonstrate kind of what we're doing by making this change and make that sort of resonate with users. What about color of PLC versus OPC? Many of you are producing architectural products, right? Or that will be a consideration. So different cement producers are going to report different experiences. For some, there's really almost no color difference. For others, the PLC can be just slightly lighter, and it might allow for a lower pigment dosage. So that can be really beneficial for architectural type products. In general, we say that the other mixed design factors than the cement alone are going to have a greater impact on the color of your product. That's the water cementitious materials ratio, if you got fly ash, or if you change from one cement source to another. So really, all of those other things have to be looked at in context, but PLC is potentially going to be a little bit lighter. And Joe is going to tell you a little bit more about that from a producer's perspective. So I'll turn it over to Joe here.
Okay, I wasn't quite ready, but I am ready, and that was perfect, Jamie. I mean, everything you covered, a lot of what you covered. I am going to go in, just do a quick recap and give you more of a cement producer's perspective, and things that Jamie had covered that I'll touch on briefly. Cement in general, color, gray versus white, blend fineness, strength, set time. We will talk about the mixture design regarding trials, add mixtures, adjustments, and then last but not least, article I put together on PLC. Next slide, Jamie. As we look at the cement color and the blend, they tend to, in my opinion, coincide together. And I'm approaching this more from a white cement supplier point of view, but this will impact, as Jamie mentioned, white or gray. The cement color oftentimes does lighten up a little bit when you're adding PLC or limestone, make it a PLC cement. The blend tends to increase. That's not always the case. It's going to go by plant to plant, but typically when you add that limestone, because it is softer than clinker, in a finish mill, the fineness does tend to increase. The blend compared to the control, what I'm saying there is PLC blend versus the control. My type 1 versus a type 1L. Typically, you're going to see very similar, slight increase. As Jamie mentioned, it could increase maybe 1,000 points. Every cement plant and every product the cement producer is moving, what you want to do is pay attention. Look at your current cement that you're using today. If you do change over to a PLC or try it, look at the blend. It will have a direct influence on what you're trying to do. The higher blend does impact the finished color of the concrete, and then the lower blends do affect finish color. It will actually darken it. So, because architectural precast, you are looking at oftentimes similar color, maybe a little bit brighter. Strength and set time. Again, its strength is comparable to the control. PLC versus a ordinary Portland cement. A cement supplier typically is going to try and produce a cement that you can pull one cement out and put the other cement in and have similar performance. Part of that performance includes set time. You know, set time can vary depending on water demand, admixtures, SCMs. You know, those three, water demand, admixture, SCM, they go hand in hand. That will influence your set time. If your water's higher, water demand's up, your set time is going to increase. With architectural concrete, my advice is when trying a Portland limestone cement is if you see the water increase, my suggestion is you might consider bumping up your admixture to compensate for that additional water demand. That will help you maintain color. And then last but not least, strength and set time. These are all influenced by the blade. Next slide. Oops. Mixed designs. Shorten the learning curve. You know, and again, Jamie covered this. You know, I've used this term, the cookie cutter approach, that where you pull one cement out and substitute another and expect the same performance. It works occasionally, and occasionally it may not work. You know, my advice is, as Jamie mentioned, test. You know, if you have a quality control program in place, this should not be a problem. Smaller producer, you may not have a strong quality program. Approach it with a cookie cutter approach. Test the concrete, see where you're at, and consider if you want to make adjustments. Work closely with your cement and admixture suppliers. This is a given. Both cement and admixture suppliers, those guys are selling you products that's coming to your plant quite often. You know, use their services. They do more than just sell you a product. Next slide. Admixtures and pigment. You know, again, we touched on admixtures. Admixtures, it's going to have an influence on water demand, set time, and strength. All three work together. Again, it depends on what you are accustomed to and what you can live with. You know, use your admixtures to your advantage. As a cement supplier, my view of admixtures is admixtures oftentimes complement the performance of my cement. They have a great staff on hand. They know their product. When you have problems, it's just a matter of picking up the phone and explaining to them what you're seeing. They may be able to adjust you quickly. Pigments. The first APA webinar was on pigments that Jimmy did here a month ago. And with pigments, because of that increased blend or slightly lighter colored cement, you could possibly see a slight decrease in your pigment loading. Chances are you won't see enough that you'll want to adjust. The trials that I have seen using pigment with white cements in the market, the PLC cements, there were no pigment adjusting needed. Admixtures carried the weight when water varied, and that the finished color was a very close match. And then last but not least, color of the finished product can be impacted by water demand and pigment loading. And again, APA, as an APA producer, you're selling color. You're selling that finished product. So you want it to be the same. And then last but not least, there is a resource available. I sent this to John here a while back, but basically what we're covering today. Is John has a article he can email you. It's just quick and simple on everything I just covered. And if you want, reach out to John, and he can hook you up. Thank you, Jamie. It's all yours.
Thank you, Joe. I think it is good to have a producer perspective, and like Joe said, they are there. He's a technical representative, a technical assistant. He can help you with issues that you're having. They want to hear from you, and the feedback is always great. So I'll wrap it up here in just a couple more slides. If you are working with producers that find lead value, then or designers, you do have some potential to get a credit for a Portland limestone cement use. So there's a lot of activity in the environmental product declaration space right now, or the EPDs. A type 3 is a product specific EPD. So that means it comes from this producer. So you may get credit by having it, by turning to the producer and asking for that. And if you can demonstrate that you're reducing your global warming potential versus a baseline design, a maximum of up to 2 points that you could get for this, and it applies to ready mix concrete and grout for masonry. So again, there's a potential benefit in using these materials. People want to see movement, they want to see numbers. We, as part of that effort, created these industry-wide EPDs, or average environmental product declarations for cement producers in North America. We did it our first time in 2016. We revisited that in 2021. These have a 5-year life. They are designed to be looked at periodically to make sure they are representative of materials that are produced. The top line number, it contains a lot of information, but the biggest number is really the global warming potential, or GWP results. And what I can tell you from that effort that we did in 2016 and then again in 2021 is the cement footprints are getting smaller. We had an 11.3% reduction from 2016 to 2021 in Portland cements over that time. And I can tell you about half of that came from cement manufacturers improving what they do within their plant. About half of that came from the energy grid getting greener. They buy a lot of electricity. So those things both played into the footprint of cement getting smaller. We also, for the first time in 2021, were able to look at Portland limestone cement versus Portland cement. We had enough production of PLC, and the footprint for a typical PLC is on average 8.3% lower than OPC in 2021. This gets to that idea of up to that 10% limestone additional content allowed in PLC. Now, I'll caution you, when people talk about EPDs, we're all still learning about them. They should be used as just a piece of data, a piece of information as part of that life cycle assessment. So you don't want to ever focus only on an EPD. You really want to understand what that means for your overall product. I can also tell you PLC has made an impact already. In that first 6 years that PLCs were available through the standard, we saved over 300,000 metric tons of CO2. We've got these equivalencies from the EPA where you say that's almost like sequestering carbon in over 400,000 acres of a US forest for a year. We also could say that based on all the cement that was used in 2019, if we could have switched all of that over to a Portland limestone cement, we could have saved 8.1 million metric tons. So these are the things that start to, again, provide context. Why are we doing the roadmap? Everybody's trying to get the carbon out of their products. They're all trying to do their part to address climate change. We're doing our part. PLCs are a pretty easy way to go about doing that, and they can have a significant impact. So John, I will turn it back to you in case you have any questions or other follow-up that you want to cover.
Yeah, great. If Jamie and Joe, if you guys don't mind turning your cameras on here for the last few minutes while we take a few questions that have come in via email. One is, does PLC increase concrete shrinkage?
So Joe, do you want me to start, or would you like to start on that?
Yeah, you can cover that, Jamie, because I thought that was in one of your slides.
Yeah, so PLC generally, again, all materials are different, all mixed designs, you have to test and know your materials, your aggregates. But in general, a PLC will shrink about the same to a little bit less than a Portland cement. And that's because of this very tight matrix that we create with these fine limestone particles, even going down below the cement particle size. So if you think of in your products, if you typically like to see a well-graded aggregate, that is something that is very common, is let's have all the aggregate sizes represented so we can fill in and minimize the amount of paste that we need. The paste is really the most expensive part of a concrete. We need enough of it to bind the aggregates and to provide a good finish. But if we can have well-graded aggregates, we minimize the paste content. So the same thing really occurs at the very small particle sizes, that PLC is filling in and tightening up that paste, and it generally tends to reduce shrinkage just a little bit.
All right, Joe, anything to add, or does that cover it?
No, that would cover it, John. I mean, the only thing I would add is just from a producer standpoint, we all know the effects of water. And if whether it's a PLC or an ordinary Portland cement, and there's no good control over that water demand, that water increases. Back to that shrinkage question, water and shrinkage. And as Jamie mentioned, that water is part of the paste structure. Your shrinkage will increase, so pay attention to your water.
Gotcha, thank you. Another question, when can I expect to start seeing PLC, and will PLC replace my current cement?
Jamie, I'll cover that. I mean, it's out there. The PLCs have been out and coming on strong on the gray side for the last 2 years. On the white side, you're going to start seeing it. Samples. You may see different cement suppliers offering you samples to try it. Will it replace your ordinary Portland cement? That's going to go from a plant to plant and supplier to supplier decision. I don't know that I could answer that.
I will say, as a broader industry, John, that we've heard a lot of announcements. We don't really tell our members what to produce. That's an individual decision. But we have seen a lot of plants announcing that they are providing PLC, and we've seen probably about 20% of plants now say that they are producing either exclusively or at least offering it. So the trend is there, but we don't know where it'll end up. And I would say that even where PLCs are produced in other countries, we do still see Portland cement available. So chances are it'll be available for some time too.
All right, very good. It looks like we have just a little bit time. So one more question. I see that came in from Mark Fairman here on YouTube. What are the cost comparisons between OPC and PLC?
Well, I don't know that we can answer that. Again, that's going to go producer to producer. I'll answer a question with a question. Supply and demand with what the market has seen the last couple of years. I think it's going to be similar, but I can't answer that. The industry, again, everybody's governed by a different board, and what a company decides, you will find out as they move along.
All right, very good. Well, listen, that's all we have for questions. We're right at the 1 hour mark. So let me just conclude by thanking you both, Joe and Jamie, for taking the time to present this great information today to our members. And thank you very much.
Thank you.
Appreciate it.
Thanks, John.
Bye all.